Okay, this is review 4-1. It's for math models, uh, chapters 1-1, 1-2, and 1-3. Basically, for all 9 of these, which I'm going to do the first 3 in this video, you need to determine if this is linear, geometric, or neither. If it's geometric, write the recursive rule for it. If it's linear, write the explicit rule. If it's neither, just simply write no. So, just a quick recap. For your linear, we're using y equals mx plus b, where b is your start and m is your slope. Remember, we have to find a change of everything. So it's the change in y divided by the change in x. All right. For geometric, series, we're writing the recursive rule, the rule that relies on the one before it. So to find a sub n, we take a of n minus 1 and we multiply it by, the base form is 2, but this really is whatever the difference is. All right, so it's not necessarily 2, but if you're multiplying all of them by 3, it's 3. If you multiply all of them by 2/5, it's 2/5. If you're dividing them all by 3, then this is a 1/3 right there. But anyways, that's what's going on. So those are the rules you need to write. If it's geometric, write this one. If it's whatever linear, it's that one. So here we go. Number 1, first of all, we're going to find the difference. So for this one, it's plus 1, plus 1, plus 1, plus 1. So the left side's consistent. This is plus 4, this is plus 4, 11, plus 4, and plus 4. And since it's the same on both sides, since all of those are 4 and all of those are 1, this is a linear function. This is linear. All right. And for a linear function, we need the slope, so the change in y divided by the change in x, which that's the change in y. That's the change in x. Not 4. So 4 divided by 1 was just 4. So let's write our rule. Y equals 4x. That's your slope. Now we need to take care of the starting point. The starting point is what is y when x is 0, which in this case, they straight up give it to you. So we go plus 3. If they don't give it to you, you have to back up and, count your slope out until you get to there. Okay? Number 2, same idea. This one, you're adding 1, adding 1, adding 1, adding 1. And this one we're adding 0.2, then we're adding 0.4, which I can already tell you this one's adding 0.8. This is adding 0.16 or 1.6. So they're different. So this is obviously not linear. So let's try and see if it is geometric. So what you basically do is take the first one divided by the one prior. So 0.4 divided by 0.2 is 2, so it's multiplied by 2. 0.8 divided by 0.4 is 2, so you're multiplying those by 2. 1.6 divided by 8 is also 2. So that's a multiplier of 2. 3.2 divided by 1.6, literally 3.2 divided by 1.6 is also 0.2. Okay? Since our ratios are consistent, since we're multiplying each one by 2, this one is geometric. So we're going to use our recursive rule. All right? So a sub n equals, in this case it is 2, a sub n minus 1. And this time it's 2 because we're multiplying each one by 2. All right, last but not least, number 3. Again, we got to check both sides. So we're adding 1, adding 1, adding 1, adding 1. This one is subtracting, that's 1.4. Yeah, it's minus 1.4. This one is minus 9, 10, 11, 12, 13. That's minus 1.4. 7.3 minus 8.9. That's negative 1.6. So this isn't linear. And then we're subtracting again. Again, this is minus 1.4. So this is not linear. And actually, I can tell right now that because these are all the same, and this is the only one that's different, this is probably not going to be geometric either. So again, the way you check is take one divided by the other. So you find a calculator real fast. Alright, so I just divided 10.3 divided by 11.7, and I got 0.880. So I'm going to just go 0.880. And then let's do the same thing again. Take 8.9 divided by 10.3.
I'm going to be 2 castles.
I hear you, buddy. Please be quiet for just a second. 10.3. And I get times 0.864. Yeah, and this one's not lining up either. They're similar, but it's not the same. So this is not geometric either. So in this case, this one is neither. Or actually, I told you just to write no.